we'll already continue with the lightning talks, as we are already running late a minute or so. And we ended up from having no lightning talks, or almost none, to having 2 posters full of lightning talks. So I can't promise we will get them all in. I've talked to a couple of people who have been giving a talk already at the conference, and they agreed to be moved to the waiting list instead. So hopefully people who've not been up here yet will have a chance to be on the stage as well. Could you raise your hand real quick if you have been here yesterday already for the lightning talks? Or let's do this the other way around, sorry. Raise your hand if you have not been here yesterday for the lightning talks. Now keep your hand up, please, if you have been at a poetry slam before. At almost all of you, okay. So really quick explanation. I will be back here somewhere if someone ends up taking a little bit longer than those 5 minutes. And once I raise one hand, you start with a very quiet applause. Let's try this out real quick, just so that people can continue talking, but they notice it. And then when I raise my second hand, you give the speaker a proper applause, so they have no chance to continue talking further than those 5 minutes. Now, without further ado, Dominic Gresh talking about better autocomplete with type hints. The stage is yours. That one. With the upper button, you should be able to mark things.
Perfect. So, welcome everyone. Raise your hand if you've seen type hints. You know what type hints are. That's good. So, you might know type hints for their capability of doing static checks on your code. So, a way to improve your code quality. You can add types to your code, and you can have a checker check them. But, well, I want to show you some other way in which they can benefit your code. And that is to help the users of your library. So let's say you define some, you're developing some library, you want to give it to users. It should be as easy as possible to use. You create some class, XYZ are the inputs. And here we don't have any type hints, but your user in their IDE, they will see, okay, autocomplete tells me I can use X, Y, or Z. That's perfect. They are happy. But now maybe you have many objects and you want to have different ways of instantiating these objects. So you have some factory method or some way to wrap around this object type. Of course, you want to do something interesting. This doesn't do anything. It just create my object is exactly the same as the my object in it. But yeah, so now you use this. You give this to your user, they open their IDE and they see, oof, I have keyword args. Okay, I don't know what to do with this. Maybe also, so you want to have some collection of objects. This is just the most simple collection type that you can have. It has a contains, it has an iter, it has a length. And you have some way of instantiating these collections. Again, they contain your my objects and maybe different types. But again, your user, when they use this in their IDE, they get an object from your collection. No suggestions. That's never good. So now, how can we fix this? We add type hints at the basic level. So on your my object, I mean, this already worked to get an autocomplete here, but we need these for all the other steps. So here we just add types. X is an int, Y is a string, Z is a bool. That's fine. And then at the next step, so here we have this object factory, which wraps around in it. So we need this to use this param spec, which is a feature in the typing library, used to type annotate star args and star keyword args. And yeah, if you follow along and give this wrapper method the correct types, now the user, when they go into their IDE, this was in VS Code. We also tested it works also in JetBrains. I don't know about other editors. But now the IDE can infer, okay, these are the types of that are available on this object. So in the similar story for the collection, So here we use a feature called generics. The collection can get a type, and here we use a type variable. So T is a type variable that we give to our custom collection, annotate the whole collection class, and then when we create this collection, the type checker can infer, okay, this is the object type that goes into this collection. And again, in our IDE, when the user wants to access this object, the IDE knows, okay, it's of type myObject, and it can give you a nice autocomplete. So you have happy users, but maybe, it was quite complicated type annotations that I've sort of glossed over. So your developers are maybe not so happy because they never know whether they might or might not break this autocomplete feature. So one way that you can actually test this is there's a feature called reveal type, which you can use to, when you put this in your code or maybe in some test code, and you run, for example, MyPy on it, it will tell you, okay, the reveal type of this function is it has X, Y, Z, and it returns a my object. So perfect. So you can use this also in your general type hinting experience to figure out what the type at a specific point is. And there's a cousin to that, which is assert type. And if I call assert type on my custom function, and I tell it to expect exactly these arguments, and it should return a my object, then let's say, for example, you mess up your type hints and suddenly it's just an any type. Then now, if you put this into the code that is type checked, it will raise an error and you can figure it out. So you have happy users, but you also have happy developers. Thanks.
Sorry, that would be Simon Niederberg in my memory. Is Aria good? Perfect. And after that will be Vita Midori.
So how to nice remember in Git. So exactly. So this is a situation I had a while ago. I had a Jupyter notebook where I made some plot, and this function took quite some time. So in this example here, it's 10 seconds. And I would maybe later in the day, I would like to show this plot in a meeting or so. So I would like to keep the output. But on the other hand, I also like to commit frequently. And then additionally, I don't want to have the outputs of my notebooks on Git. So I don't want the plot saved to Git. So in the end, I want to frequently commit files to Git, maintain a clean and slim Git repository. So images would take more space. So I want to avoid this. Keep the outputs locally, and then the last one is another problems I encounter with notebooks is that if you have merge conflicts, it can happen that you cannot open the notebook anymore because merge conflicts are solved on a line-by-line basis. So it can happen that it breaks your notebook. So take a step back. In the end, Jupyter notebooks are just JSON files, so they're all text. So the desires I mentioned before can actually be seen here. So if I want to have notebooks on Git without the output, that actually means that in the JSON file, I want to have the output cells empty. On the other hand, locally, I want to keep the output. So, exactly. So let's just see what normally I would do. Then I would work locally, then git add, so put the file from the working directory to the staging area, then git commit, and then push, and then the other way around. So in the end, what I mentioned before are actually requirements on the files in the working directory and in the git directory. So I try to achieve this, and I went down a deep rabbit hole to accomplish, and in the end it worked. So what I did, I hooked into the scripts that are run at several places in this pipeline or in this process. One, of course, many of you may know is pre-commit hooks. So you can just enforce something on a file before it gets into the Git directory. So this is the first thing I did. It's like, okay, we put a pre-commit hook that enforces empty outputs in the JSON file, so that we never have outputs in the Git directory. Concretely, I wrote a Python script that on line 25 and 31, you can see that I just check, okay, are the output cell and the, additionally also the metadata cell, if they are empty or not. So it quits the whole thing if it's not empty. Then I just had to add this to the pre-commit framework that it actually always runs when you commit something. Okay, so check, we never get the output into the Git repo. So the next thing is, okay, but we want to keep the outputs locally. Because in Jupyter Notebooks, you can just, there's the button clear all cells. So you could just delete everything and then commit. So we would still have a clean repo, but then we would lose all the outputs locally. So that's the next thing to do. And in this rabbit hole, I actually realized, okay, there's many more. I just knew about pre-commit hooks, but there's many more scripts you can hook in. And there's this one called Git filters, and especially Git clean filters. And that's actually taking place at the moment you Git add something. So you, in the end, have just a script that runs on your file when it's kind of copied from the working directory into the staging area. And then there's, you need to add two files. It's git config and git attributes. And in the git config, you can just see how it's defined. I just use a standard library there, and you can see, okay, it deletes the output and the metadata from standard in and standard out. Exactly. So this works. Exactly.
So Vita Midori is next. After that is Tim Hat. So go back to get your microphone, and we will hear about machine learning at Demokratisch or Demokratisch.ch.
Hi, I want to tell you about a nonprofit project that I'm helping. Who here knows what a Vernehmlassung is, or a consultation? I'm not Swiss, and I know, which is surprising, but it's, for those who do not know, there is a process when a canton or the federal government in Switzerland is preparing a new law or an amendment to a law where they request feedback on the draft, and you can comment or suggest changes to those drafts. And this already works, but it's not very digital. I mean, the consultations are online, but they are not always easy to find and participate in. So Demokratis is a portal where you can search for new consultations or filter, or you can receive notifications about what's being prepared. And in the very near future, it will also be possible to provide your feedback or participate in these consultations via the Demokratis platform. But even getting the data about these consultations is not easy. There are some APIs, but we also have to scrape cantonal websites to get the information. Each canton has its own format and design. And what we get are actually PDF documents where we have not only the proposed text of the law, but also some accompanying letters or reports, tables, things like that. So to process that, we are currently working on a few machine learning problems. One is even classifying what topics these consultations are about, like the environment, energy, security. That's useful, for example, if users want to subscribe to some certain type of consultations. We need to even detect whether we are looking at a draft of a law or a letter or some other document. And for that feedbacking feature to work, we need to find the structure of the document in a machine-readable format. So we need a way to get from PDFs with pictures and headings to something like this, like a JSON document that tells you there are a few chapters and they have these paragraphs in them, and paragraph 6e contains this text, that kind of thing. And this is something you can help us with, because after doing some initial research on this, we are about to open source what we have now, some models and some experiments. We will also make the data we have scraped and cleaned available. We just need to make sure it will be fully legal and with all the disclaimers required by law and so on. So if you're interested with helping this open source and civic tech project, there is a first issue you could look at, and there will be many more, and we will welcome any help, any participation, or even just feedback and comments. So this link goes to our GitHub project, which at the moment mostly summarizes the research we've done, but it will soon become a much bigger thing, I hope. Thank you.
Next up, we have Tim Head with Zero Code Change Acceleration.
Thank you. So my name is Tim, and I'm one of the maintainers of scikit-learn. I also happen to work for NVIDIA, and we, at NVIDIA, my colleagues have built open source libraries, and I'll talk about those. So almost none of what I'll talk about is my work. So who here uses pandas? Who here is sometimes sad because pandas is a little bit slow? A lot of people at NVIDIA are also sad. So they worked on a library called QDF, which maybe some of you already know. It's almost like pandas, but slightly different. And that meant it was quite difficult for people to adapt, because you had to have if statements in your code. You know, if you run on your laptop, you use pandas because you don't have a GPU maybe. And then if you run it on a big machine with a GPU, then you switch to QDF. And that turns out to be actually quite tedious, and people don't love it. So they spend a lot of time and learned quite, I don't know, the dark arts of the Python import system, I think is probably the nicest way of saying it, of being able to then build something where the only change you have to make to your code, for example, in a Jupyter notebook is, I don't know how to point. Okay, I won't point. But on the left, you see your original code. On the right, you see the code where in the red box, you see the one little bit of code you need to add. And you can add it, and it will run whether you have a GPU or not. And that's the nice thing. So you have to make very small changes to your code. And after that, we take care of detecting whether there is a GPU, whether the operation you want to do runs on a GPU or not. And the good thing is that code like this, which runs on some NYC, New York City taxi dataset, takes about a minute and runs in, I don't know, hundreds of milliseconds. So it is worth your time to try this out. So we did this for pandas. And because it worked so well, we then continued, because there's a library called NetworkX, which is another open source project. And there's an open source project from NVIDIA called cuGraph, which implements a lot of graph and network operations. So there, it's slightly different how you do the switching. So basically the same thing, you don't have to modify your code. In this case, you provide an environment variable when you run your script, and then it uses cuGraph in the background if it can. And it makes your code a lot faster if you have a GPU, but it will run on your laptop when you don't have a GPU. Most recently, people were getting very excited about polars, another library, and the same idea. No? If you have a GPU, you would like it to run much faster or run faster than if you don't have a GPU. And here the change after you install the plugin is a different argument to the collect function, and that speeds that up. And you might be spotting a pattern here. We're really going for zero code change acceleration, so making the amount of code you need to change as small as possible, and so that it afterwards runs on your laptop or machine that doesn't have a GPU, as well as on a machine that has a GPU. That might lead to happy pandas everywhere. And yeah, we will continue doing this for other open source libraries. So scikit-image, for example, there's a pull request to do something similar. In scikit-learn, we're working on it. And maybe the important thing to point out, all of the extensions or plugins or modifications are all open source. So you can use them for free if you want to. Thank you very much.
Next will be Joshua Schmid telling us or showing us funny slides for data scientists. Sorry, missing S there. And next up after that will be Ricardo Pereira. So please go back and grab yourself a microphone.
Thank you very much. I'm a software engineer, so this is a bit of a stretch, I guess. I'm not a data scientist, but try it anyways. Some years ago, I visited callingbullshit.org. They have a nice video series where they teach you how to detect bullshit in graphs and papers and so on. And this is just a collection of some slides I took out. So you can say more people like fresh juice. Well, and then you will find out, you're comparing apples with oranges because you just asked for juice. Actually, my animations are broken in the PDF. Then we have the causation versus correlation relation, where you can prove that storks deliver babies, but you actually forgot that the common cause is the country size. Turkey and Poland are big countries. We can advertise a lot of growth, simply shape our graph that it's cumulative. We can say that hip-hop and metal bands or band members die early, but actually we are right censoring because they are still alive, they didn't die yet. We can shorten an axis to show what we actually want to show by having big red bars. Or we can also have longer axes and be happy that they at least chose Fahrenheit as the scale for the temperature rise since the 1900s. Then we need to take care about the proportional ink. The blue one looks more like 70%, but it's actually only 50. Then it gets more ridiculous and ridiculous. What are the units? Sometimes sheep, sometimes square meters, sometimes crops. But it looks nice. Or, well, if a pizza chart has sliced or pizza sliced slices, nothing to do with percentage at all anymore. I wondered if this is even a graph. We have percentages not adding up to 100%, but still represented somehow on a person. Or we have nice glass slippers, like periodic tables, which are not periodic tables. We have tramway lines, or so for Microsoft services. This is one of the most favorite of mine. Maybe not the graph. This is also quite nice. It's rates, it's not part, so it's a derivative. They are trying to show derivative here, decrease and increase. Increase or the yellow, blue or the decrease. Or well, did you see such a fancy fence? Or such a nice fish? Yeah, and even though I can now prove that time does not pass, I hope it still passed.
Thank you. So now we have Ricardo Pereira telling us about Python superset, and then Stefan Keller will be next.
Okay, first of all, my apology for my lousy presentation skill. Well, as we all know, data context is very important for a certain meaning, quality, improving quality and decision making. And but as well, data visualization tools to remove outliers, cleaning data, reshaping the data in manners that we can discover trends and build insightful insights for the enterprise. So I think everyone would agree that perhaps if you have ever had the opportunity to work with Tableau, perhaps is the number one choice. So enrich it with so many features, but of course there is no such a thing as free meal. So it's quite expensive as the Tableau server demands lots of physical resources as well to update the dashboards continuously, providing real-time dashboards for the users. Power BI is also great and cheaper. But if you don't have any money and you need some 100% Python solution, you can go for Apache Superset. All you have to do is to create a Python virtual environment and just run pip install Apache Superset, and that will be all. So I would just like to share with you guys a simple example that this is a project that we have at Swiss Code, in which we managed to empower our data science teams to explore and exploit the data, presenting nice dashboards inside of the Apache Superset. And that data is fetching information from our MongoDB cluster and also from our hot/code ClickHouse database, in which we also store time series data and information message from our Kafka, because there is a wonderful integration between ClickHouse and Kafka cluster. So that's it. It's a free and very neat Python solution. That will be all. Thank you so much.
Thank you. Now we have Stefan Keller, and next up will be Tamara. I think you have a microphone already, so there we go.
Okay, so this time I'll draw once again an animal on the stage, and it's about pythons and ducks, and pythons and ducks are, or about under-engineering and over-engineering are the root of all evil, and SQL could save us all. And disclaimer, I'm a data engineer and also involved in Postgres and the like. And under-engineering is the root of all evil because Python code directly analyzing CSV files, that's not always a good idea. Use at least Parquet or something. But before all, and no offense, pandas are the go-to tool, right? But as the dataset grows, they become, they get on their limits. And
over-engineering is the root of all evil too, because why throwing cloud solutions and no SQL at every problem, like MongoDB? So no offense, once again. Distributed storage and cloud solutions are powerful, but not always necessary, and often vendor lock-in. Overkill for small or medium workloads, slower development cycles, higher costs, and unnecessary complexity. There's another saying, big data is dead, except for those few big companies you are probably not working for. And because, do you really need all your data as hot data? Really? That's not my notion, that's from MotherDoc, the company behind DocDB. So solution number one is just a word about SQL. Who dares to admit you hate SQL? A lot of people still think of SQL as being SQL 92, which is especially marketeers from the venture capital database startups, and but SQL 92 is from the 80s, 90s. You know, it's like Windows 3 or like that guy here, and with the Walkman. So modern SQL is much more, as you can read up. And now SQL 23 covers even graphs. Solution number one continued. SQL saves pages of Python code. SQL means processing close to the data. SQL stays performant even with growing data. So hands on your heart, who from you did ever rewrite your Python code while the data increased? You get that for free with SQL because of optimizers. 30 years of research. And another misnotion, the elephants, I call those over here, Oracle, MySQL, SQL Server, Postgres, and all those four are, yes, they are relational, but there are also multi-model database management systems which are about double the stars, get the double the stars as MongoDB. And they, those elephants even support vector data type. Solution number two, and that's the docs, that's DocDB, which eliminates sometimes the need for centralized databases and the need for over-the-top cloud infrastructure. DocDB is the SQLite for analytics. It's fast, lightweight, and it's designed for analytic workloads, and it supports modern SQL. So it fits perfectly in your environment. So let's read up an example, which I won't have the time probably, rank customers by number of nearby bakeries. Having customers as a CSV and having the bakeries coming from OpenStreetMap, of course, as GeoJSON. And so 2 pages of Python code ahead. And SQL code. Install DocDB and that's it. So the first part is reading in the data, and the second part, and that's the most important one, you see on ST distance within. This is the magic spatial relationship function which does the work of counting all bakeries around 1,000 meters of your customer so that you can rate your customer based on number of bakeries nearby in the morning. And so what's also interesting is the ST read one-liner to read the data and have the schema automated creation function, and or for example the output over there in one line where you output the data. So that's it. Even DocDB has limitations, and so to say, SQL and DocDB may save your day.
So now we have Tamara telling us about topic modeling for customer experience, and then Jan Wert will be next. Thank you.
Hi, everyone. So my name is Tamara. I work at the Cantonal Bank of Bern, and I decided spontaneously to put together a couple slides and tell you a little bit about a topic modeling project that we did at the bank, and specifically under some technological constraints. So what's the basic need for this project? There is a customer experience team in the bank, and they said, we want to understand what the main needs are that trigger any customer interactions between our customers and the bank systems or employees. So we want to improve our products or plan our product roadmap as a bank, not based on some guesses or internal dynamics inside the company, but really based on a data-led process to see what do the customers actually need. So the data that we had is around 150,000 protocols of customer interactions. So these are really, sometimes they're written interactions, and sometimes it can be a meeting or a phone call, and then somebody, like an employee of the bank, types up a summary of this interaction. And we basically, as you might have heard in a previous talk, like an obvious solution for this could be topic modeling, right? We want to get the relevant topics out of this data. But the key issue is that as a small regional Swiss bank, we cannot simply use some deep learning models on the cloud. We don't have local GPUs, unfortunately, so we have to rely on some old school machine learning technology. And also, the topics that were required are quite fine-grained. So it's not enough for us to say, oh, this topic is about housing loans, this topic is about the e-banking application, but we wanted really some more specific breakdowns of the actual customer needs, which means we need quite a big amount of topics. So the next issue we have for the classical topic modeling algorithms that we tested, like LDA, latent direct allocation, it was overwhelmed by, first of all, a lot of irrelevant words, and which include typos and, no, this is a different issue, sorry, which includes also things like indirect speech, because these texts are not written directly by the customers, right? They include things like, oh, I met this customer at this and this time, and he told me yada, 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 and only then comes the actual relevant content. So to come to the solution that we implemented, we ended up actually working with Word2Vec. Who here knows Word2Vec? Okay, it's quite a well-known classic NLP model that you can run in a very lightweight way. And at first, we actually tried to use Word2Vec to create embeddings of the whole memos, means like an average word vector, and we tried to cluster those. This didn't work so very well, but we did realize that by training a Word2Vec on all of our historical data of millions of protocols, we were able to get very good quality of synonyms. So what we actually ended up doing is generating synonyms for all of our words in the data, and this allowed us to have a significant improvement on the whole topic modeling. First of all, we reduced the vocabulary size from around 20,000 words to 3,500 words, which the algorithm was able to handle much better. And more importantly, even, we removed stop words more efficiently. Like I told you, we had an issue that there was a lot of noise in the data that we didn't need. And we generated, before this synonym solution, we generated some manual lists of words, like all these words describing the conversation, phone call, talk, everything that's not relevant, we kind of manually started preparing, but obviously it didn't capture everything. So by creating these synonyms, we were able to identify words that are within those similar words to the already defined stop words, and it allowed us to clean the data in a very nice way, including also names. For example, we had a whole process of removing people's names, place names, and things like that. And the synonymization allowed us to expand this selection of lists to more words that we were able to clean out. So I can briefly show you the Python. We have to look at some Python, right? So a little bit of the function that we wrote for this, and that's it.
Thank you. Now, next up will be Jan Werth, AI and our brain, not quite there yet, without any slides.
Thanks a lot. So the talk this morning inspired me actually to go back to this topic because it was about quantum states, right? But I have no clue about quantum states, so anything I say now, please take it with a grain of salt, but maybe it inspires you to Google that matter and to dive deeper into that. That would be great. So it's always a question like, okay, AI doesn't get conscious, and how far are we? And we actually want to replicate the brain. And just lately, they just found out that the axons connecting the neurons actually just don't transmit only electricity and signals, they only also filter the signals. So that was like, Jesus, we are decades away from understanding the brain. And then coming back to the discussion with my brother-in-law, Paul. So he was thinking, no, it's not really intelligence, right? It's just coding and so I thought, like, what is intelligence, right? Gathering data and just connecting the data. But for me, actually, the AI was already quite intelligence, right? And then my other brother told me actually about microtubules, and that was quite fascinating. So apparently, when you have an operation, you go into the OR, you get apparently benzo. I'm not a chemist as well, so please also Google that. But what that happened is this lays rings around your microtubules in your brain and prohibits them to decrease, right, or fall apart. And that makes us lose consciousness. So there are two different types, right? So one where you get one medication to lose actually pain, and the other one to lose consciousness. So there is a part in our brain really responsible for consciousness, and that are these microtubules. So this benzo prohibits the microtubule to fall apart. But now comes the interesting part, because when you look at the decay of these microtubules, they actually decay in a quantum state. And so if you look at it, it's different than if you measure it. If not, it's like the double slit experiment. You probably all heard about it. This is exactly what's happening in the brain. And never before we thought like that can't happen in our brain because it's too wet, it's too hot. This state cannot be achieved. But apparently it is. So the idea here is that we maybe have a key to the quantum world in our brain, which could differentiate us from actually a machine. Let's see. Thank you.
Thank you. Now, I also entered a filler talk, fstring.help, and since we are running out of time, I will skip over that and just show you the very last slide of it. fstring.help, it's a website that explains you how to use fstrings and a couple of tips and tricks around them based on examples. But the real talk I wanted to show, and which I entered as the last talk, not on the waiting list, is something about a quine. Now, could you raise your hand if you know what a quine is? Oh, that's like 5, maybe 10 of you? Nice. So, if someone asked me, hey, for a lightning talk, is it a good idea to show over 100 lines of code? I would say, never, are you crazy? Yet, I will do exactly that in my lightning talk, because I have a little problem. If I would show less code in my lightning talk, I would actually end up showing more code in my lightning talk. And if that makes no sense at all, in 5 minutes you will know what a quine is and how that all makes sense. So yesterday I was here, I had this idea of generating a couple of slides between lightning talks to announce the speakers. And if you were there, or if you weren't there, it was a little bit messy. I forgot what the next speaker was, and we wanted to send people back for like preparing with the microphone. And yeah, it was a bit disorganized. Someone told me, but that makes it a little bit more relatable. It's actually nice to see if not everything works out perfectly. And that was very nice to hear, but for me, if I'm on the stage, it makes me rather nervous rather than relatable if things don't work out. Even if apparently people don't notice that I'm very nervous, which is a very nice trait. So, I said I would improve that for today, and I programmed a bit of Python and a bit of LaTeX yesterday evening before going to bed, and then this morning in the train. And that starts with a couple of imports. We get subprocess, pathlib, and Jinja, a templating engine. Then we have a long list of speaker names, talk titles, PDF file names. Doesn't quite fit on the slide, doesn't matter. For reasons you will know in less than 5 minutes, I need to show all the code on my slides. Then we go for the main function, where we transform this list and zip it up with the dummy value down here so that we end up getting access to the speaker, title, PDF file, and the next speaker after that. Then we fire up Jinja, templating engine, and we configure it in a way that it doesn't use curly braces. Because we're going to use LaTeX to generate the PDFs, and LaTeX uses a lot of curly braces, so we want something else. We call Jinja to format the template file and pass those talks to it. And then we call LaTeX MK, a kind of make kind of wrapper around LaTeX to generate this very PDF you're viewing right now. Now I said I needed to include the entire code, so unfortunately I also need to show you a bit of LaTeX code. If you have never seen LaTeX before, it's horrible, but I need to show it anyways. So here we have a couple of imports essentially of a couple of packages, nothing interesting, but I just needed to show it. Here is the core logic of it, where we have a loop over speaker, title, PDF, next speaker, and we generate those slides with the titles you have just seen, speaker name, talk title, and then the next speaker. And then if that speaker has a PDF with their slides, we include that PDF again in the very slide deck you're viewing here. And now we get to the Quine part. Because what happens next is that I define a LaTeX command, Quine, which is basically just like defining a function, to generate a slide with source code. And then I have a couple of commands where now the code to generate those slides you just viewed generates itself into those slides. I think. So what a Quine is, it's a program, a little bit of code that produces itself, its own source code when you run it. Trivial in Python, it's just a one-liner, but much more fun in compiled languages. And I thought, hey, why not make this PDF include the source code to generate this PDF? I want to end with a quote from the Hackerethik of the Chaos Computer Club. Man kann mit einem Computer Kunst und Schönheit schaffen. You can create art and beauty on a computer. And of course, the slide also needs to print itself, so the entire source code is on the slides. Thank you very much.